Welcome to my session. I'm Marcia Villalba, and I will be talking about CI/CD for serverless applications. I'm a developer advocate for AWS, and I've been doing serverless since the beginning of it. I had my first serverless application in production in 2016. Considering that Lambda was launched in 2014, this was quite an early on. I'm also the host of a YouTube channel called Fubar, where I post 2 or 3 videos every week about serverless and cloud, and I'm running a lot of interviews with experts and also tutorials, so go and check it out. It's a very technical channel where you can learn a lot about AWS, and also I'm very active on Twitter, so if you have any questions and I don't get to answer them today, ask them on Twitter. I'm always happy to engage in conversation there. So today's talk, it will be about CI/CD. It will be about the process of releasing software from the serverless perspective. This is a talk that will be focused a lot in AWS products because I want it to be practical and that you can go and build after this. And if I make a talk about CI/CD processes, it can be very abstract, and I want that you get something. You will get a lot of code that you can take and reuse in all your projects after this talk. So that's my idea for today. So we are going to cover the 4 main stages of the release process: the source, build, test, and production. And these are, I will not go into the details because this is an intermediate level talk. So I will just give an overview on what you should expect in each of these stages, but then we will just move on to the technology. So in the source, we are expected to see the code for the last time. We are checking in our project files. There can be Java files, there can be Python files in your case, JavaScript files, whatever. You are doing your peer reviews, you are doing all the automation that you want to do in the source, in your GitHub repos, for example. And then you commit it and you will have the build phase. In the build phase, you will compile your code, run your unit tests, do style checkers, like all these fun things that you want to do. You will also create your deployment artifacts or packages, and then you will move to the test phase, where you will be running your integration tests, load testing, UI testing, security testing, whatever testing you need to do. And finally, we move to production, where you are going to deploy your production to your production environment, and you're going to monitor that everything is good. And if there is any error, you will catch it right away and you will fix it. So this is, in a nutshell, the release stage process. So the continuous integration means automating from the source to the build. You put code in GitHub and it builds a package automatically, and then you do the test and the production manually. Then the continuous delivery means that everything is automatic, but there is a manual step between going to production. So this is, I think, one of the most common ways of doing this automated release process, because a lot of companies and projects have like requirements to do some manual QA, or even they have for keeping the integrations in sync, they need to release on specific days. But if you want to go all in automated, it's called continuous deployment. And I need to close this so I don't see it because, sorry, my Zoom controls were in the middle and I could not read my slides. So that's kind of it. But we are not going into the details of which one is better and which one is not. That's up to your project. I think for me, the most important thing is that you have as much automation as you can. If you can go with continuous deployment, that's great. But if you do continuous delivery, that is also great. So if you want to orchestrate this pipeline with these 4 stages, you need to have something that takes care of the orchestration. You can do it, you can code it, or you can find some tools that do it. In the case of AWS, we will talk about CodePipeline. And this is the service that allows you to do continuous delivery for your applications. So you can update your applications and keep them on sync and deploy new features to the cloud. So this one is really cool. It allows you to visualize your pipeline. So you can see, we'll see it in a moment, how the different actions and stages are doing, and you can do different builds, testing, deployments to different environments. It integrates with a lot of AWS services, but also with third parties. So if you like to use Jenkins for building your code, or you like to test with some third-party tool, you might find a way to integrate it. So we are going to look in some of the details of this today. So this is an example of a minimal developer pipeline. So we will have 3 stages in the most minimal pipeline. We will have the source, then a build stage, and then a deployment to a testing environment or development environment. So we have 3 stages and 1 development environment. And in this case, we are using for our source code commit. I will talk a little bit about it, but it's basically a repository for code. Then for building, we are using code build, and we are also going to talk a little bit about it. And that will build our artifacts. And then we will use CloudFormation for deploying our application to the cloud. We will talk a little bit about CloudFormation and what it is. And finally, we will run some integration tests with Lambda functions when everything is deployed. Then if we want to have a more complex or a more realistic pipeline, we have this 5 stages pipeline where we are going to do the source, the build, then deployment to testing, deployment to staging, and deployment to production. And then each of these ones will be put in a different AWS account. You can, I think a good practice is to have at least your production separated from the rest, so you don't deploy your development and your production in your same AWS account. So that's something you want to keep in mind when you're building these pipelines, that you can separate these things. And here you can find all the different variations for testing, for integration testing, and for deployment. So if you want to start a build or you want to kick off a release, there is many ways to do it in CodePipeline. For serverless applications, you can use code commit or GitHub, basically some new pull request, some change in a branch or whatever. Then S3, if there is a folder or a directory or an object that you're following and something changed, you can trigger a release with that. And that's quite useful to integrate CodePipeline with other services that are not supported. So for example, there is a way around if you're using GitLab that you put your code into S3, and then when that thing changed, then their CodePipeline release start. So that integration with S3 is really helpful to go around the source repositories that are not supported. And finally, we have CloudWatch events that are like your nightly release or your release every Sunday or whatever. It has like a scheduled way of doing releases. So this is how it looks. We have the 4 stages here in our pipeline, and we will be looking at this pipeline in little detail more in this presentation. We have source, we have build, we have stage, and you can see that they all have different amount of actions inside. And this is the visual representation of it. You can see that everything is succeed and everything is good. And basically this application has been deployed into staging and it has been deployed into production. So in order to understand a little bit more about CodePipeline, it's good to understand what are the components. The first one is the stage. A stage has a name and a lot of actions. Actions have also a name, but then actions can be either AWS actions or third-party actions like this GitHub or running Jenkins, or they can be AWS actions like using code commit, code build, CloudFormation. And then when you are invoking those actions, you need to maybe give some artifacts and they will return you some artifacts. For example, in the case of code build, is a service that will build you an artifact. So it consumes source code as a zip and it returns an artifact. So that is something we need to specify when we are configuring this. And then it needs to have an order number. So in the case of the deployment stage, we have 1, 2, and 3. But if we will have 1, 1, 1, it means that they will all run in parallel. In this case, it doesn't make sense because the first action consumes the second action artifact. So it will be very hard. And this is how we will define an action in infrastructure as code, a stage, sorry. And we are going to look a lot of infrastructure as code because as DevOps, we want to have everything is infrastructure as code. And basically, I will share with you the infrastructure as code for the particular pipeline that we just looked. And you basically, by changing a couple of variables, will be able to reutilize it in your environment as many times as you want, because that's the magic of infrastructure as code. So now let's look at my CloudFormation file. CloudFormation, I will talk a little bit more in details, but basically it's the native way to define infrastructure as code in AWS. It looks maybe not the nicest thing, but it's very, very helpful if you are trying to build infrastructure in AWS. So this file has around 400 lines. We are not going and look at them, but we are going to look at the stages and how they are defined in this file. So the first stage is the source. And basically here we can see the name of the stage and the action. Then we can see that this is a GitHub action, a third party, and we need to have the owner, the repository, the branch, and an OAuth token, I can never say that word, in order to connect to that GitHub and get that code. Then the next action is build action. We are using code build. I will go in the details on each particular stage in a moment. And there we can see that it's an AWS service to build, and we need to give the import artifact and the output artifact name as well. Then we have the third stage, that is the stage. And here we will see that we have the create change set, execute change set, and Lambda run test. The first two are how we deploy things using CloudFormation in the cloud. Basically, we are going to build the artifact once in build, and then in the create change set, CloudFormation will put the right variables in place in order to deploy in the next step in the execute change set this application in the cloud. So we are building the package one, and then depending on the environmental variables on which stage we are or things like that, we will build the package and deploy it. And then finally, we have this Lambda run test that allow us to run some integration code in the cloud. So finally, we have the production that also has the create change set and execute change set. But before that, it has a manual approval that we need to basically go and tick a box in order to deploy to production. So that's our manual approval. So we will look at every step in way more detail now. So if you want the code for the pipeline, take a picture of this QR code. It's available and you can get it. And it's as simple as changing your GitHub. We were using the parameter store to set up the GitHub configuration. So just go ahead, get the right GitHub tokens and blah, blah, blah in your parameter store for AWS. And then you will be able to use that repository. If you don't know how to do it, just ping me and I will give you some documentation on how to change the parameter store. So now let's move into the first step on our release process, that is the source. In the source, we are focusing on the code, but also we are focusing on infrastructure, because in serverless, we tend to build the code and the infrastructure of our functions and some resources at the same time. So as I said, for infrastructure, we are using CloudFormation. CloudFormation is the native way of AWS to define infrastructure as code, and also it's a service for building and rebuilding your infrastructure applications in AWS. So it's two things. It's just a language, like a scripting language, and also a service. And this is a little bit complex, but after you learn it, it's your best friend to make anything inside AWS. But if you want to get started with CloudFormation for serverless, I will recommend you that you start with a framework called like SAM, for example. SAM is the Serverless Application Model framework, and it's a framework that is built on top of CloudFormation. So it will give you a lot of shorthand syntaxes for defining things that are inherently serverless, like functions, APIs, Dynamo databases, event source mapping. So you don't need to define that in CloudFormation. That will be way longer. And then when you are using SAM, that will kind of synthesize in CloudFormation at the end of the day. So basically, you can always extend all your SAM templates with CloudFormation. So this is how a SAM template looks, and I will go into the details of it. The first bit is just to tell CloudFormation that we need to transform this into CloudFormation. This is SAM. Then there are around 20 lines of code, and there you will see how to create a Lambda function, the code for it. You will see the information to create a role for AWS. You will see the information to create an API gateway. Everything will be defined in those 20 lines of code. If you want to do that with CloudFormation, it will be way longer. So here is the function configuration that tells where the code is, what is the runtime. Then we have the permissions for the function that we are giving. We are going to talk about the SAM policies. They're a great way to make your permissions way easier. And then finally, we have the definition of the API gateway and the event source all in the same thing. And then finally, we have a really simple way to define a Dynamo table with 5 reads and write unit capacity. So you don't even need to type that in CloudFormation. So this is a really simple way to create your first serverless application infrastructure. If you're using SAM, you also get the SAM CLI where you can package, deploy, do all kinds of things. If you're running it in your computer, you can try this SAM deploy dash. That's an error in PowerPoint that likes to combine my dashes, guided. And this will help you to set up everything you need in order to deploy. So I totally recommend you to try that. Then in SAM, we have a lot of functionalities besides the basic things. We can define some globals. Some globals are a great way to not replicate the same information in all your function definitions. If you have multiple functions defined in the same file, in your same infrastructure file. So if all your functions are using Python or Node, you can say, okay, they are all using that. And then you don't need to say that in all your functions. If you want to give the same memory allocations in all your functions or the same timeout or things that are common in all your functions, you can do that in the globals. Then we have the SAM Policy Templates, and these are also shorthand ways to create permissions for your functions. And these are a great way to use SAM, because defining IAM permissions in AWS, it's kind of hard if you don't know how to give the permissions. So if you're using these SAM policy templates, they already have the right amount of permissions for doing the tasks that they say they do. So for example, here you will get permissions to do all the CRUD operations in a DynamoDB table that you can specify the name. If you want to find all the policies that are available, take a picture of this screen. They're all listed there, and they are all listed how to use it. So they're a great way to add security. And most of the common use cases are in SAM policy templates. So you might not need to even write your own template documents. Another thing I really like from SAM is the capability to integrate with the AWS Lambda environmental variables. Basically, these are key value pairs that you can dynamically pass to your function. And this is a great way to make your code abstract of which environment is running. So you can make your code that work for testing, staging, and production. And if you later add more environments, you don't need to change the code. So you just have these environmental variables that get fed into your function when they are deployed. So a way to have a function is in your function definition, you pass the environment property, then you have the variable listed there. In this case, I just one. That is a table name that I'm just defining the table name once in my infrastructure, and then I can share it with my function later. So if this table name changes, then it changes everywhere. So this is how it looks in my code. This is JavaScript, sorry, but you can do the same with Python. I'm just not a very good Python developer. So all my examples are in JavaScript, but this works for Python and Node are in the same level in the support for Lambda. So whatever you can do with Node, you can do with Python. But basically, this is the way to call it. If you are using Python, you need to use the right way to get your environmental variables in Python, but it's as simple as that. Another cool thing is that when you are using CodePipeline, you can override these parameters from the stage. So if you want to pass the environment that you're going to deploy this function, and then you don't need to hard code it in your code. So for example, here I'm passing the environment staging to my function in the change set, in the create change set. So basically when the CodeFormation script is being created for deployment before the execute change it, as I was saying before, then this will put the right parameters. So this is how my SAM template looks. Then we will need to define all the different allowed values for my environment, or we don't need to, but we can. We want to have a set of allowed values for our environment, dev, staging, and prod. And then you can write, if you want to have multiple names for your Dynamo tables. So you have different Dynamo tables for development, staging, and production, different queue names, different resources name in general. And then when you create the resource, you can write that last line that it looks very ugly, but basically what it's doing is finding in that map with the right environment the name of the table. This looks ugly, but it really saves you the life a lot of time. When you are trying to deploy a Lambda function into multiple stages, you build once, you deploy how many times you want. So this is a very important practice when working with serverless applications. Try to keep your infrastructure as abstract as you can from your stations of deployment. Then I mentioned code commit. This is a source control service like GitHub, fully managed by AWS. So if you cannot use GitHub or you don't want to use GitHub, you can try code commit. It works more or less the same way. You need to have an AWS account and give permissions and things like that. Everything is encrypted when you're using that, and everything is managed by AWS. So it's a great tool, and you can check it out. And now we can move to the build stage. In the build stage, we have code build. Code build is a fully managed service to build. So you can compile source code, run unit tests, run linting, do whatever you want. Usually when serverless applications, we produce some artifacts that will get deployed later. This is cool because it scales and it can run in parallel. So if you have multiple builds going on, it's not like when we have a Jenkins machine in our office that we are limited to the capacity of that machine. This is in the cloud. So if all your company is running deployments, doesn't care, it can host it, no problem. It can take environmental variables from the parameter store, so you can make changes dynamically. You don't need to manage any server, so everything is totally managed for you. So when you're using code build, you will get basically a Docker container that is very empty, and you need to install a lot of things that you need in order to be able to run your test, create a package for your application. So this is how it looks, for example, for another Node application. Sorry that all my examples are in Node, but I have no experience with Python. But I imagine it's the same. Here, it's a super simple script. Basically, it's packaging our application into this package template YAML and uploading it to an S3 bucket. But this one is not a very realistic build spec. This is a more realistic build spec. Don't worry, I will go step by step. But basically, the build spec is the file that you use to build your application. This sits on the root of your application. You can configure it if you have it somewhere else, but by default, it sits in the root of your application, and code build will look at this script and do what is in there. In this case, we have 4 phases. The first one is to install. So as I said, this is a Docker image that doesn't have anything. So we need to install everything we need in order to do our task. I will install Node, I will install SAM, I will install Curl, I will install, I don't know, Node.js, I will install the CLI, everything you install here. And at the end, I install my application. Then we need to run the unit test. I will run them and I will validate. If something fails in each of these phases, you will get an alarm and the whole process will stop. So this is good. If your unit test don't pass, then that's it. Then finally we are building, and here I'm using SAM to build and to package, and then we will upload this package YAML file that is our package application into some S3 bucket, and that's it. I don't do anything in the post build, but you could write some tags, do some notification, do whatever you want. It's a machine that you can write any bash scripts that you can imagine. And finally, we have the artifacts definitions, and this is what the next phase will consume. So this is a very important thing. We need to keep this path and name in our eyes. So as I said, this is what the next stage will use, in this case, to deploy this application into the cloud and to build the change set that will be deployed. So we need to pass the path of our application. So you can see here that it has build artifact as zip, and then package YAML, that is the name of this thing. That's our artifact. Good. Now we can move to testing. In serverless, there is many places to do testing. Maybe we are used to do our testing in the build phase, but in serverless, we can do it anywhere. So when we talk about testing, we might not be talking about a stage of testing. I will be talking a lot of things you can do in the staging or phase, but I also will talk about other testing capabilities that you have when you're doing serverless testing. So for example, this is our pipeline that we saw before. We can run pull requests. That's something that we have been doing. You can do some automatic code reviews or linting or whatever you have in your source. Then in the build phase, you can again run your linter, your syntax checks, your unit test, and check if your code is compiling or working properly. Then when you deploy, you can check that everything is deploying correctly. You can run integration tests against mock dependencies or services, or you can use full integration test against end-to-end as well. You can also call third-party services like the ones that you see in the staging, like RunScope that runs API testing, and there's many other supporters in CodePipeline, for example. You can do QA manual testing and have a manual approval. You can do pre-checks before deployment and then have canary deployment for safe deployments, and then do post-deployment checks and things like that. I will show you about that in just a second, but there is so many places that you can test that it's quite crazy. So if we want to use Lambda functions to perform integration tests, we need to write a Lambda that looks like this. The first bit is write your integration test. That's something I cannot tell you. Again, sorry, this is a Node. And then you need to call the AWS SDK, the code pipeline, and put a message in this job successful result. So basically, you will add a Lambda function to your actions that will do the integration test, and when the test passes, you need to put a message in this place. If not, then the action will run forever. And then if your show failed, you need to put an action in this other show failure result. And this is how you define your Lambda integration test in your staging as an action. When we talk about this CloudFormation that I showed you at the beginning, this is how it looks for running a Lambda test. Basically, it's the action type invoke. The owner is AWS. And then we need to provide the function name as an ARN, Amazon resource name. That is a standardized way to give names in Amazon. We pass the outputs and input artifacts. If Lambda needs something, in general it doesn't, but if it needs, then that's it. We need to put the region and then in which order in our stage it will run, and it will run. And here you can do very creative things. You can run a lot of testings on your APIs or in your functions. If you want to run end-to-end test, they have launched a new service called Synthetics. It's kind of new. It's not in my presentation yet, but I should add it. It's a CloudWatch functionality that allows you to create a kind of canary. So it's a check-in on one endpoint, and you can perform kind of end-to-end integration tests on live services. So this kind of CloudWatch Synthetics will be really cool in the production phase. I will talk a little bit about that later on. If you want to read more about how to use Lambda functions to perform integration tests, this is the place to go. I will leave this in the screen so you can take a picture and save the link. Then we have the third-party services to test. They are adding more services all the time. These are the ones that are supported for now. And again, there is a link there to see how you can integrate with each of them. We have Jenkins, BlazeMeter, Ghost Inspector, UI testing, Micro Focus, Storm Runner Load, and RunScope API monitoring for now, and more are coming. And you can use these services to do testing. So this is cool. And also you can use CodeBuild to do testing. You can use the AWS device farm if you are deploying some applications. So there are other options as well. If you want to do manual approvals, basically that little box that says review and opens something like this, then you need to write an action that is extremely simple that looks like this. Again, the code is in that GitHub repo that I show you. And then finally, we have CodeDeploy. That is one of my favorite services in this whole presentation that will allow you to do deployments of Lambda. It also takes other kind of things like instances and containers and whatever, but I will be focusing on Lambda. And it does safe deployments, meaning that you will deploy not on top of what you have, but in a new place. So if you need to roll back, you can roll back automatically, instantly. So that's great to avoid downtime. And if you have any errors, you catch it and you are back again in the version that is working, and you can do a lot of interesting things. So if you want to use safe deployment is as easy as in your SAM template to add first auto-publish alias to be able to detect when something changed. So you need to put something, whatever you imagine. I always put live. Then you need to choose what kind of deployment strategy you want. We have basically 3, all at once, basically going all at once. And you might be thinking, why I would like to add all at once if I already have it before? Well, first, it will be deploying in a different version, so it will not be on top of what you have exactly right now. So if something failed, you will be able to roll back. Then it will allow you to do the pre-hook and after-hook test that I will be talking in a second. And you will have all the alarms as well in place. So all at once is quite useful. Then we have canary and linear. Linear means that every, for example, every 10%, we increase, every 10 minutes, we increase 10% in the load. So it will go linearly, having more and more load in our new version. And canary means that we will have, I don't know, 10% for 30 minutes. And after the 30-minute pass, then we will have 100% of our load there. So you need to pick which one you have. These are the ones available. Then we have the alarms, and the alarms are pretty cool. They will be monitoring your application, and if something fails, you will get an alarm and the whole deployment will roll back. So for example, if you are doing canary, where you are going to deploy 10% in for 10 minutes and then the rest, the alarms will be looking during those 10 minutes, and if something triggers an alarm, then poof, it rolls back automatically. And that's super helpful. You don't have, not even the 10% gets affected by the error. And then we have the hooks. The hooks are Lambda functions that run before and after you start sending traffic to your application, so you can do all kinds of things. And this is where I was saying that all at once is kind of cool, because you get the Lambda function running before you allow traffic in, then you deploy, and then you get the Lambda function running after the deployment went through, so you can do other checks, and that's kind of neat. So let's look at an example, because this can be a little bit confusing. So we have API gateway, we have our Lambda function that has a version 1. Version 1 has 100% of the traffic. We have not deployed anything. Now we deploy version 2 of our function. And still 100% of the traffic is in version 1. The first thing will happen when we are deploying this version 2 is the pre-traffic hook will start running, and it will validate that everything is well. We are doing canary, so for the first 10 minutes, we are only giving 10% of the traffic to the version 2. And if there is no error, no alarm gets triggered, then we are migrating 100% of the traffic. Version 1 has 0. And then we can run the post traffic hook, and if everything is well, then the deployment is completed. How it looks in our console, it looks like this. We have one shop that is in process. I think it's also using canary. And here you can see that it says 10% complete. The pre-validation deployment has been running, and now it's kind of stuck there until the 5 minutes or 10 minutes. I don't remember how long I put it. 5 minutes, then it will kind of migrate the whole traffic. So if I do this, then the whole traffic will start moving forward in right a second, and we will see the traffic shifting and the post-deployment validation running, and voila. So this is the visual way of seeing it. And finally, we have the production, and in production, as I said, we have CloudWatch, and we have X-Ray. These are ways to monitor our application. I was saying about CloudWatch synthetics. They are not in this list, but they're super cool. They allows you to monitor your application. You put an endpoint and you say what kind of things you're expecting out from that endpoint. And then that will run that kind of call to your endpoint every, I don't know, time you specify. And if something goes wrong, then you will get a notification, an alarm will get triggered, and things like that. So that's kind of a nice way to have our continuously running end-to-end testing in your application. Also, another cool thing that CloudWatch has is the CloudWatch anomaly detection. So it will analyze the traffic for your last 2 weeks. And if something goes out of the normal, you get an alarm triggered. So I will totally recommend you to watch sessions from Danilo Poccia about monitoring and observability in serverless. He talks all the details about all these new features on CloudWatch. It takes another 40 minutes of your time to go into the details, but I think they are very tied together with CI/CD, so it's very important to understand them. And then we have X-Ray, and X-Ray is a service that allows us to follow traces, because serverless applications are extremely distributed and you cannot debug them because, well, you might not own the code for everything, like if it's using your Lambda function and then going to a queue and then going to a Lambda function, how you debug that. So for that, you can use X-Ray. And for doing that, you need to configure X-Ray before deploying and making sure that everything is configured correctly in your application, so you can do some debugging in your application, live debugging in the cloud. And then if you want to get started, there are multiple ways to get started with CI/CD. The first one is to find a working template pipeline. You can go to this one that is in the AWS samples. You can go to the one that I gave you early on in the presentation. That's another one. The only things you need to modify basically is your GitHub access and a couple of things. And then you will have a working pipeline that you can deploy in your AWS account, and it will do whatever you need to do. It's pretty straightforward. Then if you go to the Lambda and the console, to the Lambda service, and you go to create an application, you will be kind of navigated through the experience of creating an application, and there you will get an CI/CD pipeline in CodePipeline. You don't get the template, but you get the pipeline done, and it will deploy this application automatically. You will also get the SAM template for this, and today we just announced that you also get in the CDK template if you want it. CDK is another way of another framework to infrastructure as code. So if you're into that, you also get it from this experience. So this is also available in the Lambda page when you are creating an application. So this is how it looks. You can see the deployments and you get everything, all the information there, and you can also visit CodePipeline with the application development. So basically, in a nutshell, what we talked about today was a lot of different services. I know this presentation can be very intense if you're not an AWS user, but I don't want to have a very beginner presentation, because a lot of people talk from the very beginning's perspective on how to get started with CI/CD. And I think that's pretty straightforward to deploy a hello world. But when you want to deploy a real application in production, you need more tools and you need a more complex understanding on how things are. So we talk about code commit and GitHub integration with CodePipeline. We talk about code build and integration with CodePipeline. We talk about different tools for testing. We talk about CodeDeploy and how to save deployment and immutable deployments. We talk about X-Ray and CloudWatch to monitor your production. And I think this is kind of the environment that you would like to have, the ideal environment when you are working with serverless applications. You would like to have 3 different AWS accounts, 1 for each environment. Keep your secrets either in the secrets manager or in the parameter store, not in your code. Keep all your environmental variables as well separated, and then you will have multiple resources for each of these services and in each of these accounts. But then one SAM template that will build one artifact that will get deployed in all these different environments. So that's the ideal you want to get. So that's it for me. If you have any questions, I will hang out here for a while, and then I will be also, I'm always on Twitter, and I'm in my YouTube channel. I have many videos on this, so please go and check them out and ask if you have any questions.